My name is Katherine Medina de Villiers, and I teach in Alexandria City Public Schools at T.C. Williams High School. And today I'm going to be teaching you about a binary search. So, what are you going to learn today? Well, one, you're going to learn that computers, we use various algorithms to solve problems, and searching, especially now in a data driven world, has become quite important in huge sets of data. So some of the central knowledge you're going to be looking at is, what really defines your different types of searches, especially a binary search. And in cases of, is a binary search really the best way to go, or just hit it one at a time, like in a sequential search? So one of the things I'm going to ask you to do right now is look up the Price is Right clocking miracle. I promise it's a really cute video. Watch how the lady picks the numbers. And sorry, spoiler alert, she does win at the end. So take a look at it. And then the second time, write down the numbers. And we're going to look at her pattern later. So think about it. Think about if you had a whole bunch of numbers to pick from, like you're searching and you just like got these numbers and they're in a big bag and you really can't see them. See, that's the other thing. It's like, how do you go about searching for numbers when you really can't see the number that you're searching for? Like, remember, computers can't see, they don't have eyes. So we have to think of different techniques of how we're going to search for this number. You can actually just throw the numbers in a line, just line them up. Think of like marbles with numbers on them. They don't have to be in order, and you can just pick them up one at a time. So if I'm searching for the number 31, here I would start, oh, 10. Nope, 14. Nope. And you go down the line until, wow, oh, 31, I found 31. Or in this case, maybe 27. And if I was looking for 27, I would have four comparisons or four look ats down this line. And this is called a sequential search because you're going just straight down the line. Well, let's look at a different technique. Let's look at something called a binary search. And in a binary search, one of the things we have to do is put the numbers in order. It could be ascending or descending order. And we're going to go approaching this by, well, a divide and conquer. I mean, if we have them in order, if we go straight down the middle, then we know, well, to the right, the numbers are going to be greater, and to the left, the numbers are going to be lower. So, with that in mind, that's the approach we're going to take. But you have to remember the computer still can't see the numbers. Computers know about indexing of a list. So, what a computer does in this particular algorithm, it's going to take the lowest index. In this case, it's going to be 1 on our list with the highest index, add them and divide by 2. And it's going to go to that spot to find the middle number in that range. So in this case, it's 7 plus 1 divided by 2. The index is 4. We go to index spot 4 and pull the element, which happens to be 27. So a binary search with this list of numbers in order, looking for 27, we would get it on the first pull or the first look at. So looking at the binary search, let's look at it from another visual perspective, like what we call binary search tree. And if you look, this tree, okay, the computer doesn't hold this tree in its memory physically. It's just a physical representation of what's going on, of how the search is playing out. But this tree represents kind of like the division by 2. So 27, my top node here, or the middle of the largest range. And then if I look to the left of 27, those are my smaller numbers. And if I divide that range by 2 in half, I'm going to go to index spot 2. I'm going to get 14. That would be my second look at if the number was lower than 27. Correspondingly, so if I was numbers greater than 27, my second look at would be 35. But what's interesting is that each range is being divided by 2. So my range from 1 to 7, the index is, excuse me, the sum is then divided by 2. I hit the middle. Then the smaller range, I hit the middle. So in the worst case, I'm only going to have 3 look ats. I only have 3 levels here. So back to the Price is Right. So if you wrote down the numbers, you could see that the young woman, she started off with 193, but then her numbers started getting strategically. She started cutting down the middle of her ranges of numbers when she was told higher or lower. So in some way, she was like doing a kind of a mock binary search, and she wins $1,000 at 749. So again, binary search, divide and conquer. And a lot of times when the lists are really big, we want to know what is going to be the worst case scenario. So if you have a list of 600 elements, in this case numbers, all sorted, what is going to be the maximum number of times it's going to take to find a number? AKA, like the binary search tree, what are the number of levels? How many times you're going to divide by 2? So if you look over here, 600, and I keep dividing by 2 to get to only one number left, it's only going to happen a maximum of 10 times. So that is the worst case scenario that you would have looking for a number with 600 sorted numbers. So let's look at an example. Over here, we have a list of numbers and we're looking at, well, let's look at a sequential search again. I'm looking to find the number 54. Well, I got to go down the line one at a time. And remember, they don't have to be sorted, but in this case, it's going to take 6 comparisons. But the binary search, the conquer and divide by 2, I'm going to hit straight down the middle. 32 happens to be here in the middle. And then a 54 is greater than 32. So I'm going to go to the range to the right of 32, hit it down the middle again. Okay, I'm on the second level, 54, and I find the number 54. It only takes 2 comparisons. And a list like this, worst case scenario would be 3. But so far we've been talking about numbers, but I don't want to go ahead and misconstrue your thoughts about really it's only about numbers. It's not. You can do a binary search on a list of words or strings because let's face it, we can put things in alphabetical order. As long as the user can put that list in an order according to the rules of their road, they can use a binary search. So here I'm looking for mango. Kiwi is in the middle index spot. Don't forget about those index spots. So using a binary search, I'm going to go to the index where kiwi is at. Look up, kiwi's not it. Mango is further down on the alphabet. So I'm going to hang to the right and it's going to wind up being my second look at. So I'll find it on a second pull of the element. But remember, it doesn't always have to be ascending order. It can be descending order also. So here's just a quick example of you can still do it in descending order, but then you have to remember your higher numbers are going to be to the left and your lower numbers are going to be to the right. So let's recap. Binary search must begin with sorted data, excuse me, either ascending or descending. It's a divide and conquer. You're dividing by 2. Okay, your data list can contain also words that are sorted alphabetically. The binary search most of the time is more efficient than a sequential search, which just is line up and pull one at a time and see if that's your target value. So here's a couple of practice questions. So I'd like for you to pause the screen, go ahead and take a try at them, and then we'll be right back. Well, welcome back. Hopefully these are the answers you got. For number 1, 16 is the middle number. Okay, so remember we're doing one base indexing here. So your first index number will be 1. So then you're going to add that to the largest, divide by 2, and then go to that spot and pull the number. For the second one, the value 22 is in index 5. And then for the third one, it's going to take 3 comparisons to find 31 for a binary search, but sequential search is going to take 6 because you're going all the way down the list. So I'm hoping this helps out with this question set here. Let's look at another practice set. Go ahead and pause your screen and we'll catch up. All right, welcome back. So for number 4, you can use 1 in a binary search. It's words, but they're in alphabetical order. You can't use 2, they're not in order. 3, it's in reverse alphabetical order, so you still can use it. And 4, they're numerically in ascending order, good to go. And for 5, 200 sorted numbers, you're going to divide by 2, a maximum of 8 times. That's your worst case or maximum number lookup. So what should we take away? Take away that binary search is an algorithm. It's a conquer and divide. It has requirements. The list has to be sorted ahead of time. Most of the time, it is the best way to go. So I really hope you've enjoyed learning about the binary search with me today. See you soon.